Hello students, hope you are fine and enjoying my mathematics class. In this lecture I am going to discuss about the basic things, the basic concepts which are necessary to understand the broad topic, that is fluid dynamics. So this is going to be something more interesting because fluid, which we are always using in our day-to-day life, we can see so many examples like you can see with the blood which is flowing in our body continuously, and water which we are always using for many purposes, right? But we don't have the exact knowledge or exact idea about fluids. Many of us thinks that fluid means which can flow, and many of us thinks that fluid means only liquid, which is not exactly correct. Okay, so let us come to the definition of fluid. That is, write down the definition. Okay, so a substance which is capable of flowing and deform continuously under shear stress. Okay, so you can take one example. That is, if you will take a bucket which is full of water and you will apply force in this way, then it will continuously deform its shape. Okay, so water is a best example of fluid. So in general there are three types of fluid. Okay, one is your liquid. Okay, second one is vapor, and third one is gas. Okay, so in liquid it is incompressible. Okay, but in case of vapor and gas it is compressible. Okay, and if we'll talk about the molecules, in liquid molecules are very close to each other. Okay, but in case of vapor and gas, molecules are present in a open space. Okay, so in generally we can define fluid in this way, but if you will see the property of fluid, then we can categorize fluid in two ways. That is, one is your ideal fluid. Okay, so ideal fluid means the fluid which is incompressible, okay, and having no viscosity. Okay, no viscosity means if you will applying force or not, its flow will not stop. It will flow continuously, which is not possible, right? So this type of fluid does not exist in real life. But the second one, and that is a real fluid. Okay, so the real fluid is the fluid which is compressible and has a viscosity. Okay, that means you can take water which is slightly compressible, okay, and has viscosity. Okay, again we define a real fluid in two ways. Okay, so again real fluid is defined in two ways, that is Newtonian fluid and non-Newtonian fluid. So what is Newtonian fluid? Newtonian fluid means the fluid which obeys the Newton's law, right? That is, shear stress is directly proportional to du by dy, you can take, which is velocity gradient. Okay, and this is shear stress. Okay. So if you will remove this proportional sign, then you can write some constant mu into du by dy, where mu is coefficient of viscosity. Okay, so this viscosity plays an important role in fluid dynamics. That's why briefly I will discuss about viscosity in one class. Okay. Similarly, if we talk about the non-Newtonian fluid, that is the fluid which does not obey the Newton's law. Okay. So if you are taking the example, then water is the best example of Newtonian fluid, and the gel is example of non-Newtonian fluid. So this is about the fluids. Now come to fluid dynamics. What is that? And this is the study of, okay, so study of motion of fluid flow along with the force causing the flow. This is nothing but our fluid dynamics. Okay, so this force we will calculate based upon the Newton's second law. What is that? Now F is equal to m into A. Okay, so what is this force? This is our resultant force or net force. This is mass of the fluid, and this is acceleration of the fluid in the direction of force. Okay, so if we will assume the force in x direction, then we can write Fx equal to m into Ax. Okay, so there are 5 types of forces acting on a flow. Okay, let us discuss about this type of force. Okay, so first one is Fg. Okay, this is gravity force. So second one is Fp. Okay, that is pressure force. That means force due to pressure. And third one is Fv, that is viscous force. Okay, that means force due to viscosity. Okay, this is one of the important term. I'll discuss it later. Next is Ft, that is force due to turbulence. Okay, what is this turbulence? Now, when the flow is flowing in a very high velocity, what happens? The particles, those are present in the fluid, they starts to jump randomly from one plane to another. Okay, this is nothing but the turbulence. But in the similar case, if the flow is flowing in a line, okay, smoothly without jumping from one plane to other plane, in that case the flow is called laminar flow or streamline flow. Okay, so force due to turbulence, right? Now come to last one, that is force due to compressibility, is nothing but Fc. Okay, force due to compressibility. Okay, so these 5 types of forces acting on a fluid flow. Okay, so if we combine together, we can write Fx equal to Fgx, okay, plus Fpx plus Fvx, right, plus Ftx plus Fcx, right? And this is the general form of the force acting on a fluid flow. Okay, so from this general equation we can derive so many important equations which is important for fluid dynamics. Okay students, so let us derive one by one. So this is the general form of the force acting on a fluid flow. Okay, so first, if you will neglect this FCX, okay, that means force due to compressibility. If you will neglect, write down. So from here we can get a Reynolds equation. Okay. Similarly, if we will neglect these two forces, that is Ftx and Fcx, okay, then your Fx will be Fgx, right, plus Ftx and Fbx, right. Ftx, Fcx, if we will neglect, we will get Fx in this part, which will give us the famous one, that is Navier-Stokes equation. Okay, Navier-Stokes equation. Okay, and the third one, that is if we will consider only these two forces, okay, that is Fx equal to Fgx plus Fpx. Okay, so this one will give us the important one, that is Eulers equation. Okay, so these three equations are the most fundamental equations for fluid dynamics. Okay, so how we are getting this Eulers equation, that one I will discuss in the coming class. Okay, hope whatever up to this I explained, hope you understood. Still, if you have any doubt or anything you want to suggest, then you can write it in the comment box below the video. Okay students, thank you.